Well, welcome back, and I'm sure you noticed you saw a very interesting portrayal of how to change decimals that terminate and repeating decimals into their decimal equivalents. I'm going to show you even a little bit of a more of a shortcut that I allow people to use because they're the type of decimals we encounter all the time, but I'll get to that in a couple seconds. So let me share the screen again, get the sheet up here I want, and away we go. All right, let's take a look at these fractions. Now you remember, I'm sure, how to change fractions into decimals. You divide the bottom by the top, right? So that's a very simple process. So pick up your phone or your calculator, all right? And let's divide these out quickly together. On your calculator, take 7, and let me turn the calculator on, that probably would help. 7 divided by 8, and of course that gives you 0.875, right? A nice terminating decimal, all right? 0.875. Should put a 0 out front. 8/15, of course you know you divide 15 into 8, or on your calculator the 8 goes in first, obviously, right? So 8 divided by 15 yields for us 0.53 with a bar over the 3. The 3's repeat forever. So that's a nice repeater. 2 and 15/11. Well, just remember you can put the 2 down there, right? Not 15/11, 5/11, sorry. Now you divide 5 by 11. So take 5 divided by 11. And when you do, you get 4, 5, 4, 5, 4, 5, 4, 5 forever. So it's 0.45 bar, okay? 6/7, you may remember this from middle school and high school, that the sevenths repeat in units of 6 digits. So this will be -4 point, and you take 6 and divide it by 7. And when you do, you get 0.85714 then it starts over again, 8571412. On your phone, you can tell that better because it shows you more digits. Remember, you turn your phone sideways to make it a scientific calculator. This whole unit right here, okay, repeats. All right, 39 1/11. All right, so you put down your 237, and you take 39 and divide it by 111. And when you do, you get 0.351351. So it's a repeater like so. And of course, 7/18, all right? You put down the 905, you hit 7 divided by 18. And when you do, you get all 8s after a 3. So 3, 8, 8, 8, 8, 8, 8, 8 keeps on going. Rounds to a 9 on your calculator, but it is repeating 8s. Okay, so you recall that. How do we go back the other way? Well, you know what? I'm not even going to make you learn what you saw in the video you just watched before this. I thought it'd be of interest to you to watch that video. I thought it's very well explained, and I thought that maybe we should come up with a simple method. It's very common for us to have decimals that start right out at the decimal point and start repeating, like the 2 I'm circling right now. Now, you know what? The Kelly's Teeter method, I didn't invent this, but I call it the Kelly's Teeter method. And you can use the Kelly's Teeter method to convert these back. Are you ready for this? It's this simple. You take, how many digits are repeating in 4545454545? 2, right? So you take your 2 digits, 45, and you put it over the same number of 9s, 99. You know what? 45 over 99, if you can reduce that, it reduces to 5/11. Guess what? For the 237.351, this only works now when the decimal begins to repeat right at the decimal point. You can simply just take 351 and put it over 3 nines. And guess what? If you reduce 351 over 999, it'll reduce to 39 over 111. It turns out that 9 goes into both of those numbers, okay? And it reduces very nicely to 39 over 111. I will never make you reduce your fractions once you convert them either, okay? So now, with that being said, let's go down and practice some of these, all right? Some more of them, all right? So let's go here. The 0.78 doesn't have a bar in it, so you just put it over its place value, 78 over 100, and then you reduce it, 39/50ths, right? But look at this one, 0.9 bar, 1 digit, right? The 9s are repeating. I put it over how many 9s? 1. Wait a minute. Does 0.9 bar equal the value of 1? Turns out it does. Turns out it does. Those repeating 9s do a very weird thing. You can mathematically prove, and I'm not going to bother doing that now, that 0.9 bar is exactly the same mathematical value as 1. Imagine that, right? Okay, 0.324 repeating. You simply take 324 and stick it over 3 nines. And you can leave it like that. You don't even have to reduce it. I'm not going to require you to reduce it on the test. Just remember, that is the correct answer. And, okay, so it's very, very simple process. And you can simply write the Kelly's cheater method, and I'll accept your answer. Okay, let's go on. 0.9825 as a repeater is just 9825 over 4 nines. Now you cannot do that Kelly's cheater method on this problem because it doesn't begin repeating right at the decimal point, right? The Kelly's cheater method only works on decimals that are right next to the decimal point when their repetition begins, okay? So, and all I'm going to ask you for is the Kelly's cheater method. I thought it would be good for you to refresh your memory as to how mathematicians usually change repeaters that are of any shape or form. And you got to see that in the last video, which I asked you to watch. But I'm only going to ask you for Kelly's cheater method type ones, okay? Because you run into them all the time. So if you remember that, if the repeating starts right at the decimal point, just remember, put the number of digits down that are actually repeating and stick it over that number of nines, and you'll have your answer. You don't even have to worry about doing a massive conversion, okay? Now, let me go up to a sheet now, which is called Group Work 15. All right, I would like you to go to Group Work 15, which was attached, okay? So I want you to take a look at Group Work 15, the front of it. A lot of the sheet has been crossed out, okay? But I would like you to look at Group Work 15, and let's go through some of this. Now, the fractions up at the top, you know how to convert those into the decimals they came from. You divide the bottom into the top. I'm not even going to worry about doing those with you right now. What I am more worried about is the second group, starting with problem 7. 9875, 0.9875, if you want to convert that to the fraction it came from, there's no bar on it, right? Therefore, what do you have to do? All you have to do is put it over its place value. And of course, its place value is 10,000, okay? And you reduce that, you'll have the answer to that. But you don't even have to reduce it. That is the correct answer. For number 8, 0.25 bar, you simply put what? 25 over 99. All right? For 11.5 bar, you put the whole number down How many digits are repeating? Just one, the 5. You stick it over 9. 11 and 5/9 is the fraction or rational number that 11.5 bar came from. This one, you put down your -14. There's 3 and 6 repeating together in a group. So you put 36 over 99. And of course, that reduces to 4/11. All right, but you don't even have to reduce it. Just give me that answer. I am pleased. Okay, the next one, 351 over 99. Okay, I believe this comes out 17/33 when it's reduced. Now you got to be careful on number 12. Notice the repetition does include the 0. So in other words, when this 11.027 with the bar over the 0, 2, and 7 repeats, okay, it repeats 027, 027, 027, 027 forever, okay? So you need to put the 027 over 3 9s, okay? All right, so make sure you do that, okay? All right, for 13, okay, all you do is put the whole number 2 down and put 9675 over 4 9s. That's all you need to do, and I am thrilled with that. So just do that, and you're in good shape, okay? Then you're in good shape, okay? Okay, all right. Clearly describe, again, the decimal behavior, right, of a rational number. Well, I'm not going to write it down. You know what it is. You can write it down if you can't remember it. It's the decimal behavior of a rational number is it's going to T or R. It's going to terminate or it's going to repeat. One or the other. Okay? Clearly describe the decimal behavior of an irrational number. Okay? Never T's, never R's. All right? Goes on forever. In other words, it never ends. It can have numbers all over the place, or it can have patterns in it which grow. The pattern has to grow, okay, in order for it to be considered to be an irrational number, okay? If the pattern didn't grow, it would be like a repeating decimal, and of course that's not the situation. Okay, so you've learned about here in this particular lesson the Kelly's-Teeter method, okay? Let's take a quick look at the back of this sheet, okay? Remember, I keep hitting you with this because it's going to be on the next test, and I want you to make sure, all right, that you know how to do this. All right, to get a rational number between 738.020305 and 020308, you need to take those two numbers, add them together, and divide them by 2. When you have done that, you will get this number, which is exactly halfway between them. Am I finished with this problem? As a matter of fact, I am, right? Because that's a rational number, it terminates, okay? Now, I could have put a bar over the 6 and 5, and it'd be 6, 5, 6, 5, 6, 5 forever. That still would be between them. You just have to make sure, if it's a rational number, that the number is really between the two numbers in question, okay? All right, let's go to the next one. We want an irrational number between these guys, all right? So let's see. If I divide those two, add them together and divide by 2, I would get this. There's a 0 I could put there, a 0 I could put there without changing the value of the original numbers. That number is right between them, but it's rational. I have 3 choices that I can do to show that this is an irrational number. Add a whole bunch of numbers to it, like 3, 1, 8, 6, 5, 9, 2, dot, dot, dot. And simply, I will realize that you mean an irrational number because the numbers are all over the place. Okay? That's one way. What's another way I could do this? Another way I could do this is to do what? I could simply put an arrow after it. The arrow would say, and I could put some numbers before the arrow if I wanted. That arrow is a Kellyism, but it tells me you know what you're doing and that you understand that the numbers continue and go all over the place. You don't put 3 dots because the 3 dots would mean in the same pattern, and you know I wouldn't know what you mean there. All right, but that's not my favorite way, right? My favorite way to have you do this is to stick a pattern on here. Now, you've got the 6, 5 there, right? But I'm going to use a different number. I'm going to use 3 numbers, 1, 2, 3. Okay? So I'm going to put 1, whoop, I got to get the pen turned on here. I'm going to do 1, 2, 3, 1, 1, 2, 3, 1, 1, 1, 2, 3. I'm going to come down here and keep going. 1, 1, 1, 1, 2, 3, dot, dot, dot. That is definitely an irrational number showing a growing pattern. And that is acceptable. But that answer would be wrong if you forget to put the 3 dots after it. The 3 dots tell you that it continues in the same pattern. Don't forget the 3 dots if you elect to show your answer in that method. Okay, what else is on here? Well, there's a credit card problem on here. We're not doing credit cards, right? But you, I'm sure by now, are very familiar with how to do UPC codes, okay? So, of course, I would want you to multiply everything by 31313131. Maybe we should do it real quick just to make sure you're comfortable with it. I multiply everything out. This is a fairly simple one because there's a lot of zeros in it. And it turns out there are no 2-digit numbers in here. So this makes it pretty simple. All right, so I add these up. 13 and 4 are 17, 18. Hopefully I'll have better luck this time. 18 and 3 is 21, 24. So 3x plus 24 has to come out equal to 0 mod 10, right? So what am I going to do here? Well, I'm looking for a number that produces a digit on the end so that when I add it to 24, it ends in 0, right? Well, it appears I'm going to need a 6, right? What number do I need for x to have the number 3x end in a 6? Well, it turns out it's just going to be x equals what? 2. 2 times 3 is 6. It certainly ends in a 6. 6 and 24 adds up to 30, so you know we're good. X has to be equal to 2 for this code for Jell-O chocolate vanilla swirls to be shown correctly with the right type of UPC code. Okay? Now, with this all being said and done today, what is it that I want you to do, all right, for homework after this particular video? Okay, I'm going to ask you to do the following. I'm going to ask you to do group work number 13. There's only a few parts to that, okay? And I would like you also to do just a few parts that I haven't crossed out on group work number 16. I would also like you to complete video quiz number 13. just text me the answers only to Video Quiz 13. Take your time and do a good job on that, okay? I don't want you to mess that up, okay? Might as well get that 10 points, all right? All right, now, there's just one other thing I want to quickly go over today before I close out today's class, and that is this. I want to go over with you writing something out for me in a particular way. Okay. What if I tell you you are only allowed to use 9s and 5s to make these kind of numbers? Okay? I would like you to make me 3 rational numbers, 3 of them, which have only 9s and 5s in them. All right, well, let's see. 5/9 only has 5 and 9s in them. 0.95 bar is a rational number that repeats with only 9s and 5s. Okay? 9/5 it also is going to be a decimal. Okay? And that decimal, I believe, comes out 1 point. I'm not even sure. Let me divide it out and see. 5 goes in there once with 4 left over. 4/5 is 0.8. So this is just 1.8, but I can't use 1.8 in that form. I want this form with only 9s and 5s. I could use 59.9559, 9559, 9559 with 3 dots after it. That is, of course, a rational number which is showing repetition, but not with bar notation. In bar notation, it would look like this, right? Okay? All right? All right. I would like you to write for me 3 irrational numbers with just 5s or 9s in them. All right? Well, one of them could be like this. 5.95955. There's an infinite number of answers you could write for this, okay, that I would accept. So I have to look at everybody's answers to make sure I am pleased with what you have written and that it is correct. I'm putting a pattern on here, right? I didn't do it right. I need 3 5s there. I need 4 5s here. Dot, dot, dot. So there's one. Let's come up with another one that's irrational. These are the irrational ones, right? Okay, what else would work? Well, I'd have to use some kind of combinations with 5s and 9s, right? So I could do 9.95, 995, 9995, 9999, 5 dot, dot, dot. There's another irrational number with that. I could use 5, right? And then I could use what? 3 9s and a 5. 4 9s. Well, I've already done kind of that. So let's do 3 9s and a 5, 3 9s and 2 5s, 3 9s and 3 5s, dot, dot, dot. All of these three examples right here all show growing patterns, don't they? And growing patterns, all right, like what I'm showing right there, work very well, all right, in terms of producing for you, all right, an irrational number. Now, the next class we get together, I am going to review everything to get you ready for the test. I'm going to use 2 sheets for the next class, which will have all review material on it to get you ready for the next test. After we have finished that class, I will send you the test, all right? And you are to complete big quiz number 2. I would prefer you completed it for me as soon as possible, but if it takes over the weekend for you to get it done, that's fine. But I just want for you to remember one thing. I'd like it by the end of the weekend, okay? I'd like it by the end of the weekend. Now, after this next class that I am putting together for you, which puts together the review, I'm going to again start new material. Now, I do want to say a couple things about this new material. It's going to be quite different than any of the stuff we've just been doing the last several classes, all right? First of all, I want to say that we're going to visit geometry quite a bit. Don't worry, it isn't proofs and all that stuff, but we're going to visit geometry, and we're going to take a look at how the golden ratio comes into play. But one thing I don't particularly like about the beginning of some of these videos that I did, they are the first ones I made once COVID set in. So you're going to see me addressing the topic of COVID quite a bit in some of these videos. Just ignore that because we're kind of by that now. But I want to use the same videos. The only problem with them is that the camera I was using at the time wasn't tremendously clear, all right? It was in my laptop, but I ended up buying new cameras because I was not pleased with the picture. Not that I wanted to look good, I don't mean that. It just kind of looked a little fuzzy. So you're going to see that some of the videos that we're going to work on for the next classes might be, particularly ones I made using my laptop, are going to be a little bit fuzzy, okay? Also, I want you to be aware that I'm going to be assigning you videos most likely to watch at home, not during when we have class together, okay? But I'm going to ask you to do the class, and then after the class is over, I'm going to ask you to watch some more video material before you watch the next video that I do supposedly with you. So it's going to get a little more intense with that. Almost all these videos, I made them, all right? But there are some very good professional ones in there also, and the authors are going to jump back in. So I just want you to be aware that all that's going to be happening, and I'm going to start that right after we have done the test, okay? So be aware of that. So, and the COVID comments or whatever I might say in relation to hoping your family is well and all that, you know I mean that, but we were in the midst of the COVID crisis at that time, and a lot of people that I was dealing with when I taught that, finished the spring semesters and used those videos, were living in New York City, and it was crazy down there. So please be patient. Don't worry about it. Also, the coding system that I use for the videos all has dates on it, like April 4th, April 10th, April 20th. Just ignore that. I will put those dates in parentheses when I tell you what video to watch. I will classify the videos the way I have been, except when you click on the link, when it comes up, it's going to be the name that's in the parentheses. It's not going to be the name you're used to seeing, which is usually COVID video class such and such. It's going to be the thing that's in parentheses, like the date April 5th or April 20th. So don't be confused by that. Just go to the links. The links will be correct, and you can watch the videos as I teach you the material. But also, you are to watch a lot of the videos at home on your own, middle of the night, early in the morning, whenever it is you want to watch them. So please be aware that after the next video that I do with you, which will be pretty clear, all right, there's going to be a few that aren't exactly perfectly clear, particularly the review videos that get you ready for the second big quiz. Once the big quiz is over, okay, there'll be a couple, 3, 4 videos there that aren't the clearest in the world, all right? But they'll clear up better because then my cameras arrived and I used those to make the rest of the videos for the rest of the classes. So please be aware of that. So if you get confused, you can always call me or text me and ask me, hey, you know, I'm lost here, where are we going with this? But it'll be pretty self-explanatory when you watch what I ask you, when you watch my videos that I have produced, because you'll know exactly what you're supposed to do. Just follow right along on the emails like you have been, and you should be just fine. Okay, so with this being said, let me refresh your memory again, okay, of what your assignment is going to be. It is these 3 things. I would like you to do any parts that I haven't crossed out on group work 16, any parts that I haven't crossed out on group work 13, and I would like you to complete video quiz 13 for me and text me the answers to that quiz. There'll be a lot of video quizzes coming up after big quiz number 2, and some of them are going to get quite a bit longer, as you're going to see. So it's going to be a pretty intense group of classes once you finished big quiz 2, but it'll go all right. It'll be geometry. I think you'll find it very interesting. Some of these topics are stuff all around you never even realized, and hopefully you will get something out of them and be able to carry them on through your life, pass them on to your family or your kids, and explain to them these various things as we go on. And the last thing we're going to do in the course is we're going to talk about coincidences, and we're going to use probability to talk about that, why coincidences take place. And so that will be coming up also, okay? But that's, you know, down the road a little bit. So that's the very last topic I will discuss with you. So focus please on getting these 3 things done, group work 13, 16, and video quiz 13, and getting those to me. And be very careful to take the time to watch the videos that are going to be coming up in the next class, which are going to help you review and get ready for the next test, big quiz 2. By the way, I'd just like to say it's half the length of the first big quiz you took. It's only 2 sheets, a front and a back. That's it. All right. So don't worry, it's not near as long as big quiz 1 was. So big quiz 2 is about to be in your future. We're going to have 2 videos that you're going to watch in the next class to get you ready for that. So I will see you for the next class. Please get this homework done for me, and we will definitely be talking soon. And I hope all is well with everyone. Take care. Bye-bye.